Hello, and welcome to an introduction to functions. My name is Tuesday J. Johnson. I'm an assistant professor at Doña Ana Community College and a lecturer at the University of Texas at El Paso. This is for Math 120 Intermediate Algebra at Doña Ana Community College, also New Mexico State University. I'm using Turner McKeague's Intermediate Algebra, the one with the cool parrot on it. It's by XYZ Textbooks, Chapter 3, Linear Equations and Two Variables and Functions, Section 3.5, Introduction to Functions. So let's start with relations. We have two definitions for relations, and we're not talking about your cousins here. Mathematically, a relation is a rule or correspondence that pairs each element in one set, called the domain, with one or more elements from a second set, called the range. All right, so a relation is a rule that pairs elements together. We could also say a relation is a set of ordered pairs. The set of all first coordinates is the domain of the relation. The set of all second coordinates is the range of the relation. They're saying the same thing, but sometimes one clicks for some people and the other one clicks for others. So slightly different way, same exact meaning. Let's look at a couple of examples. A couple of relations. Here's a relation. It's a set of ordered pairs. 2, 1, 4, 3, 6, 5, and 8, 7. The domain is the set, so we have some squiggly brackets here, of all first coordinates, 2, 4, 6, and 8. The range is the set of outputs, the set of all second coordinates, the y values, the 1, the 3, the 5, and the 7. Notice it is not an interval from 1 to 7. It's just these four specific values. So not an interval of numbers, but specific ones. In example number 2, my domain inputs 0, 1, 2, oh, there's a 1 again. We don't waste our time writing repeats, that's all right. The range is 4, 6, we already have 4, so I'm going to put in 5. The fact that my order is messed up probably bothers a few people. It doesn't bother me at all. But the fact that I don't have a squiggly bracket there really does bother me. Bad typo. So the range should be for the set 4, 5, and 6. So from a relation we get functions. There's a special type of relation, and once again we have two definitions. A function is a relation that pairs each element in the domain with exactly one element from the range. Exactly one. A function is a set of ordered pairs in which no two different ordered pairs have the same first coordinate. Remember, the first coordinate is domain, second coordinate is range. Let's go back and look at those same examples. But now let's determine which one is a function and which one is not. Example 1, 2, the input goes to 1. 4 goes to 3, 6 goes to 5, 8 goes to 7. This is a function as each x goes to only one y value. You tell me the x, I can tell you exactly which y value we're talking about. Example number 2 is not a function because 1, the x value goes to 6, and 1, the x value goes to 5. Two different ordered pairs, same domain value, but they have a different range value. That's not okay. The fact that 0 goes to 4 and 2 goes to 4, that doesn't matter at all. What matters is a single x can only have one y value. This x value of 1 has two different y values, so that's what ruins it being a function. So we have a visual way of testing for functions. Using the definition of a function, we can use something called the vertical line test to determine if a graph is the graph of a function, and it says, if a vertical line crosses the graph of a relation in more than one place, the relation cannot be a function. However, if no vertical line can be found that crosses a graph in more than one place, then the graph represents a function. Let's take a look at some examples. I'm going to call these 9, 10, 11, 12, and 13. Once again, I took them right from the book. I love the instructor materials provided with this textbook. If I take any vertical line, so I'm looking at vertical lines here, vertical line. Any vertical line touch the graph of 9 in more than one place? No, this is a function. What about number 10? Take any vertical line, do I touch the graph in more than one place? No, this is a function. But number 11, here's a vertical line. Let's take a green line that, oh, you know I'm not going to be able to draw a vertical line. Hits the graph in only one place. Awesome. But here's a vertical line that crosses, pretend it's vertical, that crosses the graph in more than one place. And because it crosses a single x value, has 3 different y values in this case, this is not a function. I only need one time for a vertical line to cross the graph more than once for it to fail. But this one actually has many infinite lines, vertical lines that make it fail the vertical line test. Getting tongue-tied here. Number 12, vertical lines. Vertical lines. Yep, that's a function. Number 13, nah, that's not a function. That's not a function. Here's a vertical line that crosses the graph twice, so that's not a function. And number 14, what do you think? Is that a function? Well, if I take any vertical line, I'm only going to hit the graph one time. So 9, 10, 12, and 14 are functions, whereas 11 and 13 are not. Vertical line test, great way to test if a graph is the graph of a function. Thanks for listening.